When most people see the Greek phalanx, they just see a big block of soldiers. But that's kind of like calling your smartphone just a piece of glass. What we're going to do today is deconstruct the Phalanx for what it really was, an absolute masterpiece of combat engineering, a high-performance system that turned basic physics into pure battlefield dominance. And it all starts by solving this one single brilliant design problem. It's a question every single soldier in the ancient world faced. How in the world can you make one shield do the work of two? The answer to that question, well, it's the blueprint for one of the most effective war machines in history. Think about it. If you're a lone warrior, no matter how good you are, you're exposed. You've got a weapon arm and a shield arm, right? You just can't cover your entire body and attack at the same time. Your right side, your weapon side, is almost always open. This is the fundamental weakness that the Greeks decided to engineer a solution for. And their solution was, well, it was genius. They just stopped thinking about soldiers as individuals. Instead, they started thinking of them as components. And that is the core concept here. The Phalanx isn't just a formation, it's a human integrated circuit, where every part has to connect to create one single, incredibly powerful system. The key piece of hardware in this whole circuit is the Aspis shield. Now, this wasn't just some big, round shield you hide behind. No. Its design was so clever. It was specifically built to not only protect the man holding it, but to deliberately extend past his body to the right. And you have to ask, why? Well, it was for the guy standing next to him. Okay, so here's how the structure gets built. Your own shield covers your left side, but your right side, your sword arm, is vulnerable. So what happens? The soldier to your left uses his shield to cover your exposed right side. Now, multiply that down the entire line and bam, you've got it, a seamless interlocking wall of bronze and wood. This really just nails the whole point. A Greek hoplite wasn't supposed to be some self-sufficient hero. He was a component, basically programmed to do one job: hold that line and trust the man next to you. His survival literally, and I mean literally, depended on his neighbor. You can imagine the kind of unit cohesion that creates, not to mention a nearly unbreakable defensive wall. But a wall is just a wall, right? It's defensive. What made the Phalanx a true weapon was its engine. And this is where we get to move away from structural engineering and into pure physics, the raw application of force. This engine was called the Othismos. It literally means the shove. And listen, this was not just some chaotic, disorganized push. It was a coordinated, terrifying application of compressive force. The guys in the back ranks, they weren't really there to fight. They were there to push. They were the power source for the entire machine. So here's the crucial difference, right? Static versus kinetic force. When it's standing still, the Phalanx is a static wall. It just absorbs the energy of the enemy attack. But during the Othismos, it becomes a kinetic weapon. It's a wall in motion, delivering this crushing wave of energy right into the enemy line. It completely transforms from a shield into a battering ram. So what happens when you combine this incredible interlocking defensive circuit with a powerful kinetic engine? Well, you get a weapon system that just dominated battlefields for centuries. Just try to imagine it, 8 ranks deep, with the back 6 or 7 ranks all pushing forward. You're not fighting one man with a spear anymore. You are fighting the combined mass and the kinetic energy of hundreds of men, all of it focused into a single, brutal point of impact. And that's the perfect way to think about it. The Phalanx stopped being a group of individual soldiers, and it became a single, living battering ram. It didn't just break enemy lines, it absolutely pulverized them, grinding them down under this relentless, coordinated pressure. So, to sum it all up, from the front, it was almost impossible to break. It perfectly integrated both offense and defense into one single motion. And most importantly, it weaponized the basic principles of mass and kinetic energy. Just brilliant. But okay, why does this ancient blueprint still matter to us today? Because the core principle behind the Phalanx, well, it didn't die with the ancient world, not even close. It's a truly timeless concept of system design. This idea of interlocking dependency, where individual components create a system that's way stronger than any single part, it is the foundation of our modern world. You can see its echo everywhere, in the distributed network of the internet, the precise choreography of an automated factory line, or even in the team structures at a software company. We are still building systems based on this ancient Greek blueprint. So I'm going to leave you with this question to think about. Where else do you see this principle at work today? What modern phalanx relies on each component trusting the next to create a totally unbreakable system? Let us know what you think in the comments.
We're Ancient Archive Blueprints, and our mission is to bring you ancient brilliance bite-sized.
If you enjoyed this breakdown of ancient engineering, make sure to like, comment with your own thoughts, and definitely subscribe for more deep dives into the blueprints that built our world. Go ahead and hit that bell so you never miss an upload. Thanks so much for watching.